Right, let's, where were we? We were doing radio astronomy. There we go. Right, okay, we've got that one.
I have problems on my Mac because of using like control for things in Linux
Oh, yes, yeah.
and if I use the wrong one, the thing I'm editing just disappears and I have to start all over again. Hope I
Yeah,
haven't destroyed the file.
right, so what am I doing? That's that, right. I think I'm going to move on to Raspberry Pi Picos because I think you're probably more interested in learning a bit about those. Um, what I would say is check out RMate because it's a really good way of editing on Raspberry Pis. Given that we've only got half an hour left, I think we can come back. To be honest, we could almost do a whole morning on Raspberry Pi stuff, and because I've got a GPS connected to it for getting accurate timing. I've got RTL dongles that connects to them, and we can put a project together along using that. I think in the last half hour, what we'll do is we'll have a look at the Pico because it's a great microcontroller in the respect that you can use it with Python, and it's got some really nice features on it which you don't get on other microcontrollers. So in that respect, I think it's going to prove very useful for radio astronomy. So I think I'll use my remaining time on that. Is everybody all right with that?
Yeah. It's got an exciting ADC. I was the first person to find the differential nonlinearity problem.
Exactly. Yeah.
They've
Oh, were
spent
you? Yeah.
£2 million and they've got to do a revision 2.
Yeah, I know. Yeah, well, I wasn't going to mention that. Well, to be honest, it would be problematic. But you, once you know about it, of course, you can. But it has got a problem. Yeah. It's got more than one problem, I think, hasn't it? It's got a problem with the reference voltage as well, hasn't it?
But it's good. Yeah.
But otherwise, it's good. It's got potential, definitely.
Absolutely.
Right, where are we? So we're going to go and have a look at Raspberry Pi Picos. So let's have a look at the little chap first of all. Now, there are obviously an awful lot of these like little computers out there. Arduinos obviously dominate the market, and they are very good, and I use them. I've got Arduinos, I've got all the Atmel and PIC controllers that you can imagine. And I literally bought this, obviously only came out a month or so ago, and I bought a couple of them, and I've done a couple of projects already with them, and they're actually really nice. It is, as someone pointed out, it's their first attempt, and therefore there are things that need to be improved. But what differentiates it from all those others is that the Raspberry Pi Foundation have actually built their own chip. So they've got this ARM M0 core processor. Now, bearing in mind that this thing costs less than £4 to buy, £3.90 something. So it's dead cheap. And in fact, the chip itself, they reckon is going to be around the £1 mark when it comes out on the market, when you can finally buy the chip. There are lots of other people making Raspberry Pi Pico, lots of other people making boards with this chip on it as well. So this isn't the only one, but it was the first one that came out, and that's the one I bought. It's actually really interesting. It has got some features which you don't find on other microcontrollers. First of all, it's dual core, and using Python. That's another point. You can use Python on it. So it's got a version of Python running on it, which let me just talk a little bit about the hardware before I go talk about the Python. It's dual core, which is nice, and we can use those in Python. It's got 4 12-bit ADCs on them, which are capable of sampling. Well, the standard clock on the Raspberry Pi is what is it, 180? Is it 180 megahertz? It tells you on here somewhere. Should do. I think it's 190. I think 190 meg. And they'll sample at basically around about. Well, I think they'll sample at about. I've prepared some documentation on this actually. Pico, and onto digital file. That was no, not that one. A to D. Yeah, the A to D operates at on a 48 meg clock. So it'll work up to about 500 kilosamples per second, and that's actually really quite useful. It's a 12-bit A to D. It has got, it's a successive approximation. However, it does have a flaw, and it does, as someone pointed out, but they are working on it. What's neat about that is that you're going to have like 200 plus kilohertz of bandwidth, and somebody here has actually written some code to run it as make it work as an SDR, and it'll work with SDR software. So you've got a 200 kilohertz sampling SDR basically. So for VLF, that would be really quite useful, and that's something I'd like to have a play with. So that's one feature that you don't get on sort of an Arduino or something. It also has another interesting feature, which is a thing called I/O or programmable I/O. It's down here. Look, programmable I/O. And what that is, it's got two additional cores, if you like, which only run an assembly language, but it's a it's only got I think 8 or 9 instructions. Every single instruction is only 2 clock cycles. So you can, for instance, you can generate a square wave, 100 megahertz square wave coming out of it. So you can actually do some really cool stuff, and people have already written drivers to, for instance, do HDMI out, bit banged HDMI using assembler. So and the nice thing about the way that they've implemented the Python on it is that you can have direct access to these PIO channels. So what it means is that you can write your own sort of drivers, if you like, for certain types of application. And again, radio astronomy has lots of opportunities for that sort of thing, you know, identifying pulses and you know, measuring things quickly or whatever. So it does have features on it which may well turn out to be very useful for all sorts of things like that. So yes, it's an interesting product. It's quite cheap and it's easy to use. The documentation is very good. That's one of its strong points, and there are an awful lot of people doing a lot of things with it already, so it's certainly very popular. As you can gather, I quite like it. So let's have a quick look at how you can how you actually program it. Now, it does have Python on it, and it's a version of Python which is called MicroPython, which is what they call bare metal Python. That's the sort of nickname it's got. Now, all the Python that we've been using up until now, and if you're using it on full-size Raspberry Pis, sits on top of an operating system like Linux usually, or in my case was Windows. And obviously the problem with those sorts of environment is that they are not terribly deterministic because they're multitasking environments. So if you're in Linux or you're in Windows, then in the background there's all sorts of things going on. There's I'm not actually sharing the screen, are you? So I'm pointing things out to you and you're not even actually looking at them. That's not very good, sorry. Here we go. Hopefully now you can see a Raspberry Pi. So that's the processor there. What was I saying? The advantage of the Python that's running on these chips is that this chip doesn't have an operating system running. The Python runs on the bare metal itself, and therefore is way more deterministic. And what I mean by that is that if you're wanting to do something like, for instance, controlling a motor, then everything that you do is repeatable, and the timing of that is absolutely guaranteed every time you do it. And that's the huge difference that you have from a microcontroller like this and a full-blown PC or a Raspberry Pi, that you get this deterministic behavior, which is what you need for controlling things like motors. So what we're going to do is have a bash at controlling a motor very simply on a Raspberry Pi, just so I can show you how easy using MicroPython it is to do. Now, I'm going to use Visual Studio Code, which might end in disaster. I hope not. Right, let me just file. Right, just bring that in. So if I do recent workspace and I do RA, I should get, right, here we go. So that's where we left off, wasn't it? I'm not going to use that now, so we'll go where that can go. Something's really weird here. Yeah, I need an even more powerful machine. Everything's going really slowly again. Right, so Pico, there we go. So I'm going to create a new program, I think. Let me see what we're going to start with. We're going to start with this one here. Shall we do some motor control, or what would you rather do? We have a choice. We've only got 20 minutes left. We can sample from the analog to digital converter and write to a file, or we can control a motor both from the Raspberry Pi and also from that's going to take longer. Let's do the analog reading, and we'll have to come revisit this in another workshop and do some motor control and stuff. Yeah, the sampling we want to do we? Yeah, that's getting a thumbs up from some people. So, okay, right. So, analog log to file. So we're going to write a Python program that's going to sit on our Pico. Now, first of all, how do we communicate with our Pico from Visual Studio Code? That's an interesting question. Thonny is quite good. Thonny has got this built in as well, so that's a good reason for using Thonny. In Visual Studio Code, we have to go back to the plugin section, and in the plugin section, if you type in Pico, it should come straight up, and it's called PicoGo, and it's there. Why's my pointer stopped working again? There it is. There's a plugin called PicoGo, and PicoGo is an extension which gives you complete compatibility with the Raspberry Pi Pico, and it's got some really nice features, and I'll show you what those are. Somebody's asking a question now. Hi Roo, can we catch up with your idea of using a Raspberry Pi to find the crescent moon? What the hell is that? Oh, there's Kumar. Oh, you might want to. We'll have that conversation offline, maybe. Yeah. Okay. Sorry, my head's spinning at the moment. Right. So PicoGo is a plugin for Visual Studio Code. If you just go in and type Pico into the plugin section, you install it, and then you'll be away. What is going on with my mouse? It's going weird. Right, let's go back to here. Let's get rid of that. Now, what it does is you can see now along the ribbon on the bottom, because I've got PicoGo enabled, is that I have some stuff which you wouldn't normally get in Visual Studio Code, which is to do with Picos. And in fact, if I click on all commands, you'll see that there's a whole number of commands in there which are about Raspberry Pi Picos. You'll also notice that at the bottom here there's a terminal, which we haven't really, if you don't know Visual Studio Code, but there's a terminal that pops up here, and you'll see that there's it says PicoConsole, and in fact, if I click on the Pico connected, it should, and of course it's going to not do it because that's exactly what it's going to do. It's going to piss me off. Just try this again. I know what's going on here now. I think. Right, there we go. It's connected. So you press the Pico connected button, and it's now connected to my Pico. And the cool thing about this is that we're now actually connected to the Pico. If you want to see the Pico on my desk, I've actually got a camera there. This is the Raspberry Pi Pico sitting in a breadboard. I don't know if you can see my camera. as well as, but the camera, I've just changed my camera to this one. So there's my Pico, and I've got it wired up on a breadboard, and it's connected over USB to this PC. So the Pico itself has a REPL on it. So in the terminal, it's very much like we saw before. So I can say, in here, I can say print hello. It will print. So it's exactly the same as it is on your PC. You can do all the same things. So you can, for instance, do import machine, which is the library that controls the actual thing itself. I can say help machine, and it will give me help, and it will show me all the modules which are in the machine module. So there are things like what we're going to be doing. We're going to be doing ADC. So I can do help machine dot ADC. It's uppercase, isn't it? ADC. And it tells us some information about that. It hasn't actually got all the information I need there, because I need to do a little bit more. But what my point is that there's the REPL there, so that we can say A equals 1, A, and it prints out 1. So it's exactly the same as the REPL that we had on our PC. Now, if you start a program, which we've just started, like this one here, we have to tell it that it's designed to go onto the Pico. So in all commands here, there's a command which says configure project, and you just click on that, and then it automatically knows that this program here is designed to run on the actual Raspberry Pi Pico. And I've actually got a command in here. Look, so if I actually press this run button here, what it'll do is it'll take the program that I'm looking at, and it'll run it on the Pico. So if I do run, there you go, it says analog sampling program for Pico, which is that line of code there. So it will, every time I hit run, it just runs that piece of code. I can as well upload that onto the Pico, and then the Pico will automatically run that every time it starts up. So this is during development. It will only temporarily load this up to run it. So that's quite handy. So let's go ahead and write some Python to sample the. Let's have a quick look at what we've got. We've got our Raspberry Pi Pico here on my breadboard. I've got a motor and a few other bits and pieces, which. But I've actually, what we're going to do first of all is we've got a pot, and the pot is connected to one of the AD one of the pins, which we're going to connect to the AD one of the AD converters. And so we're going to twiddle the knob and measure the value of the knob and write that into a file. So we'll have to come back and do this motor control stuff another day. But this is fun. It's a shame we didn't really get onto that, because what I will do is not only will we control it from here, but I've also got a UART and a USB TTL converter here back into the PC, so we can actually control the motor entirely from a GUI. And I was going to show you how to write a GUI on your PC to control the motor and all the rest of it, but we're not going to fit that in the next 10 minutes, so you can forget that. So the other quite nice thing that we have on PicoGo is that if you go into the help, you can see that it's got show Pico pin map. So it actually has the pin map built in. It's got a picture of it. So we're going to be using one of these ADCs. I think it's ADC0 that we're going to be using, which is GP26. So just remember that. That's where it was connected up. That's where it's connected up my actual pot. So let's go back to our actual program. So where we're going to start. Now, the first thing is on the Pico, in order to get access to all the machine components, we're going to have to import. We're going to import, get it right, import machine. Now it comes up in, that's one of the beauties of using an editor like Visual Studio Code, is that it actually shows you all the things that you can import, which makes life easy, so you can just do that. So you don't make as many mistakes with spelling and such like. We're also going to be using some time functions. So I'm going to import, it's called uTime. Time is a library which exists on Python on PCs, but on MicroPython, quite a lot of the libraries have a U in front of them because they're subtly different. So this is called uTime. And I'm also going to use a library called UOS, which is the operating system. Oops, not really. UOS, which is, we're going to use the operating system library, for which there is no operating system, but this is how we get at, well, you'll see, right. So first of all, we're going to have a potentiometer, and I'm going to call it potentiometer. And that potentiometer is going to be connected to the machine and it's going to be an ADC. So you remember when I did help machine, it came up with all the different libraries. Well, one of them is ADC. You'll also see now that we've got the help in line now. So this is the help in line, and we can scroll up and down inside there as well. Oh, that's it. That's the full. So it tells you the syntax of how to set that and how to read values from it, which is really nice. So we need in there, we need to tell it the pin. The pin is going to be machine dot pin, and it's pin number 16 we're going to use. Okay, so that's defined where my ADC, the ADC is, where I'm connected. I am also going to, that's it, that's the only one I'm going to do. Okay. Nope. Right, okay. Now, we didn't really look at functions when we were going through the basics, but functions are defined just with the word def. Now, functions are obviously modules of code which you can call. So I'm going to call this one run, and the way that you define functions is that you have the name, a unique name, and then you have a set of parentheses, which is where the parameters are passed, and then it always ends in a colon. Now, the other thing about Python is that when you're actually defining something like a function where you have a group of commands, is that group of commands are bunched together. And the way that is achieved in Python is not with using brackets and braces and things like it is in other languages. It's used by the formatting. So you'll notice now that I'm tabbed in. To got one tab in there. And what that means is that all of the commands that I'm going to put in here are actually going to be part of this run function. So what I'm going to do is, first of all, just read. Let me have a look. We're going to have to walk before we run here, aren't we? So if I do, I'm going to do a couple of different ways of doing this. We've really got 5 minutes. I can't get all this in. This is going to overrun slightly. Are we all happy if it overruns a little bit? Yeah, I mean, I understand if you want to jump out. I'm just trying to think whether to go through this step by step or whether to actually just. the bare minimum in. We wanted to introduce all sorts of complex stuff here, and it's never going to happen. Logging and all sorts. Let's get it writing to the right. So I'm actually going to have a for loop in here. We haven't talked about loops either, but it's going to say for I in range 10. And then we're going to have some code in here. I'm just going to put pass in there for a moment. So loops in Python can either be they're either while loops, which I'm not using here, or they're for loops. And a for loop is my preferred method, although I do use whiles occasionally. But the for loop will take this command here, which gives you a range of numbers between 0 and 9, and it will pass through it, taking that value with it in a local variable called I. So this will literally loop round 10 times and then fall out the bottom. And I can sort of demonstrate that to you by well, what I'm also going to put in there, I'm going to say utime dot sleep. And I'm going to say, well, say I say 0.5 seconds. So what this sleep command will do is it will, I'll take that out now, it's no need to be in there, is that it will do this 10 times, but each time it gets to this command, it will stop. The processor will be put to sleep for half a second. So this should take 5 seconds to execute. So if we come down here, now nothing will happen at the moment, so because I haven't called this function. So this function is purely a definition. Nothing will run here until I actually call it. So this is calling this function here. So if I run this, you should see, okay, pin doesn't have ADC capabilities. So why have I got it in here as 26? That's interesting. Pin map. I'm fairly sure I've got it. Oh, maybe I haven't. I've got it on GP26. Yeah. Did I put 26 in there? Ah, 16. So it'll be 26. Right, that's better. Right, run. Oh, right, there you go. So it came out of there 5 seconds later. So actually, I could improve that by doing, say, print I. Let's just do print I. So it's just going to print out the I every time it comes around here. So let me run that again. So that's just a loop of 10. Okay. So if we want to read from our potentiometer, all we need to do is in here is to say we just give it a value, so we'll call it val for want of a better expression, and then all we have to do is do potentiometer dot read, and it always returns a 16-bit value, even though it's a 12-bit ADC. It gives you a 16-bit value back, so it pads it, and we read that. So now we're going to have the value of our pot in a variable called val. So rather than, well, in fact, what I can do, I can say that and that. So now I'm going to print out a number and also val. So let's run that and see that work. And we should be getting values from the pot. Why is it not running? There we go. Now I'm going to twiddle the pot. You should see the value going down. And yeah, I wasn't quick enough to get it to go back up again. But you can see that there's a variety of values there. If I run it again, I'll twiddle it in the other direction. So it's just why it's going so slow. I'm not quite sure. So that's low, and I'm twiddling the knob, and there we go. Right, and didn't quite get to 65,000, but it's basically values between 0 and 65,535. So that's how easy it is to read from the thing. So if we wanted to write that into a file, how do we do that? Well, that's very easy. We open a file for append to an append to that file. So let me just quickly show you how I'm going to do that. So before my for loop in here, I'm actually going to introduce a couple of things to you. I'm going to throw you a few things here. So I'm actually going to do a thing called a try except. This is how you catch bugs and exceptions in Python, and it's very handy. And it's a very useful way when you are doing things like this. So I'm going to create a log file, and I'm going to say open, which is how you open a file, and you tell it the name of the file. I'm going to call it vals.txt. So that's the name of my file, and you've got to say what you want to open it to do. And I'm going to say I want to append to my file, and all that information, if you want to read it, is in this help here, and it's also in the file. You know, you can look up the file handling stuff, and it'll tell you what these characters mean. That means append. Now, the reason why I'm doing it in a try except is because if that file isn't already there, then it would say, oh, that file, because when you ask to append to a file, it has to find the file to append to. So if the file doesn't exist, I'll get an exception. In fact, I can show you that happen. If oh no, actually I won't. We haven't got time. So just take my word for it. Is that if it tries to append to a file that doesn't exist, you will get an exception. So by putting in a try except, I accommodate that, and that's the recognized way of doing things like that in Python. I know it looks strange, but that's how you do it. So if I haven't got a file to append, I'm going to create a file that I'm going to write to. So the first time I do this, it will actually operate this one. And this one, I'm going to put a W in there. And that means I want a file that I want to write to. So that will actually, in fact, create an empty file ready to write into it. So now all I have to do is write my values into that file, and then we've got a record. So that's pretty easy to do. I am going to I'll tell you what, let's just soup it up very slightly because we've got a few minutes left. Let's soup it up very slightly. Not only am I going to read the value, I'm also going to get the time. So I'm going to call it temp time. Am I going to do that? No, let's just leave that. We won't bother with it. I was going to get the time. There's a real time clock, and I was going to get the time and record the time and the value, but we can do that later on. No, sorry, I'll do it. So TMP, I'm going to call it, what am I calling it? Temp time. Silly variable name called temp time, and it's going to be called uTime, which is where all my timing stuff does. And if I do m time, that will give me the actual local time, or actually gives me the UTC time. Now the problem with that is, and if I were to print that out now, you'll see that it's in a very strange format. So I'm going to have to extract the time from that before we write it into our file. So we've now got effectively got our value from our A to D, and we've got the time coming from our real-time clock. And what I'm going to do now is log that into the file. So my file I named log file here. So I'm going to say log file. Okay. Dot write. That's how I write into my file, and then a parentheses, and then whatever I put in here, it will write into my file. So what I'm going to do is I'm going to use a format command. So I'm going to have a pair of parentheses, pair of inverted commas to say that it's a string, and then I'm going to put some placeholders in here. So I'm going to have that's going to be the hours, that's going to be the minutes, and that's going to be the seconds. And then I'm going to got to write the actual value. I'm then going to have a comma, and then I'm going to have the value of the potentiometer. So if I do format now, and then I fill those parentheses with all the elements that I want. So the very last one on the end is going to be val, which is the value for my potentiometer. But I've got to do hours, minutes, and seconds first. So they're going to be temp time, TMP, let me just, temp time, there's temp time. Now, temp time, the way I extract hours from it is I go to the, I'll go to element 3. You just have to take my word for this. I was going to show you the temp time first and then show you how to extract the time from it. But you'll just, with the time that we've got left, I'm sure you believe me. Temp time, and so hours, minutes is 4, and the last one is temp time, and it is, the value is the next one along, which is going to be 5, obviously. Oops. So it's there just to double check before I make any too many mistakes. Now I've got some squiggly thing here, expected. Ah, yes. Oh, right. How many? I've got 1 open bracket, 2 open brackets, 1 0. That should be right. Why is it saying they've got an error? Oh, I know why. Because I haven't got a comma in there. Look. So the wiggly red lines means you've made a mistake, and it was actually the missing comma that it didn't like. So what we've got there is we're writing into our file the date and the value of the potentiometer, just 10 samples. So I think that should work. We should end up with a file, and I'll show you what that looks like. And then, right, I've got there. So let's run it. So run, and I'm going to twiddle a knob just so we get some different values. There we go. So there's some values. Now, how do we see that file? Well, if we go into all commands again, one of them is start FTP server. So if I click on that, it's now running a little FTP server on the Pico, which means that I can actually use something like FileZilla or something, an FTP client. So I'm just going to run FileZilla now. Thank you. And I've got Pico set up already. So there's my file, vals. Let's stick that over here. So we'll just bring that over here. Okay. And then I just need to open that in here. Open. And there we are. The times aren't right. So I forgot to set the clock. My fault. There we go. It's actually, that file was already there, so it's appended. These are the times. This is the ones I've just done. Let me just go ahead and delete the file, and we'll run it again so we get fresh data in there. So delete that. So we go back down here to stop the FTP server. Let's run the program. Okay, let's. Oh, I was going to twiddle the knob. I'll just leave the values the same, and then at least you'll recognize it. So if I go into here and I do start FTP server, go back to my Pico, refresh that. Oops, connect. There we go, and it's there. So bring it back over here. Yes, and then open. Oh, it's empty this time. That's cool. So it didn't work at all. Oh dear, it gets better, doesn't it? Oh dear. What's it doing now? Oh, it doesn't like that. There's nothing in it, look. Why is there nothing in it? Ah. Well, you did. That's no. We've got to make it work. I can't leave on that one. Why is it not writing into the file? That's a bit odd. Why is it not running? It's not. No, it's not that. Is it?
Callum suggesting you should close the previous one.
Do you need to close the file to make sure it's written?
No, what, close what file?
The one you've created.
Vowels.txt.
I'm not actually closing the file. I was supposed to be using a context manager there. You're quite right. It hasn't closed it, has it? No. Yeah, you should really use a context manager there. I was trying to keep things simple, to be honest. But you're quite right. I should have closed the file as well. Not particularly good file handling routine. I'm just going to restart the Pi, and then it'll work this time. I'm sure it will. All right. But yeah, I think you're right. Yeah. Normally, I would have used a context manager there, so I'd have said with open and then written to it, and that way it would automatically have closed it at the end. With the way I've got it, yes, I should really have a underneath there. I should have file close, shouldn't I? It should say log file, not locals. No. Actually, log file exists in here, so it could have to be at the end of there. So log file dot close. That would sort it out. Anyway, that probably works because we didn't we rebooted it, and therefore it would have closed the file. Let's just gonna have a look. Just make sure that we're connected and it's refreshed. Okay. Fingers crossed. Yeah, there we go. I forgot to put carriage returns in as well. So you can see on there, I should have done /n or something like that. /r/n. That would have done it. Because I didn't do that, they're all sequential, which makes handling your data a little bit trickier. But there's the time and the value, and the time and the value, and time and the value, and time and the value. Oh dear. Well, I did have high hopes. I was going to do a lot more with this, but I think that's given you a little, maybe hopefully, a taste of what we can do in using the Pico. The Pico is a great little board, and I would definitely recommend you get hold of one. And it's a good way of learning Python as well, because it's a bit more restricted. MicroPython is what it says. It is micro, so you can't do a lot of that. Like for instance, matplotlib won't run on one of those, but that's not where you're going to do all your data manipulation, or rather, you're not going to do any charting and stuff on there. I mean, that's purely for the PC. So if you want to learn about the other stuff we did earlier, then that's best done on a PC. But just for sampling and recording information, what I was going to go on and do, and if we want to hold another one of these, we can, and I can take off from where I left off. What I was going to do is add to that so that we could write to an SD card. So you could have a very low power sort of hilltop recorder or something running on batteries. Because one of the big advantages of things like the Pico is that they'll run on a couple of AA batteries for quite some time. You can put them to sleep, wake them up, and take a measurement, put them back to sleep again, and they'll go for long periods of time on very small batteries. So, it's the sort of project where you can put them in a sandwich box and take them from the hills and with a magnetometer in them or something. And
you don't even need a breadboard. This came free on the front of Hackspace magazine, and
All
I
right, what's he got?
used
He's
the
got.
card and I just push pins in to make a breadboard to connect to the pins.
That's a clever idea.
That's
Yeah.
how I did the pulse width modulated output that swept the ADC and found it's the differential nonlinearity problem.
Yeah, there's quite a lot on the forum about it. I was reading it, but
I've just posted a link to it in case anybody else wants to read about it, because it's got all about how to read the ADC and put it in a file, and then put it into a spreadsheet and such like.
Yeah, well, that was ultimately what I was going to do. I was going to show you how to extract that data, and then with a GUI and draw plots and all the rest of it. But obviously, I've massively run out of time because I've massively underestimated how slow I was going to go, or how fast I would have had to have gone. I hope that was a sort of good introduction to some of the basics. What I haven't done an RTL dongle, which I was going to do. We're actually going to do some real-time fast Fourier transforms with some integration of like hydrogen line integration stuff. I was also going to do a GPS, getting the time on a GPS on something like a Raspberry Pi. In fact, it was a Raspberry Pi with a GPS dongle in it. To get accurate time for obvious purposes. What else was I going to do? Motor control, and I was going to have motor control from a GUI, so a Windows GUI with controlling a motor with the motor being controlled from a Pi 0. So maybe another morning we could get all that done.
I think we definitely need to book another session with you, because obviously you were covering too much of the basics, because there were a lot of people that needed that. So
yeah, and I don't know whether I did a good job of either, really, but
it makes us all feel warm and cozy, because an expert like you can have problems as well.
Well, it was just the like a stuck keyboard, which didn't help, but that wasn't the problem with the amount of time I'd allocated. I just, as usual, underestimated how much time these things take. So hopefully I haven't bored you all to death, and that you've actually been enthused to actually start using Python. It is quite quick to learn, and I think the main takeaways are I've given you some good publications and places to go for information, and some good libraries to play with. And I think once you start, you've got to get your fingers on it. Otherwise, just reading about it isn't the same as doing it. So that's why getting something like a Pico is a good incentive, because you can wire it up to stuff and do real stuff with it. Likewise, if you've got some data and you're staring at this big field of numbers, get it into a NumPy array and start messing around with it and doing some. And the plotting is like falling off a log. It really is. So start looking at matplotlib and NumPy. So depending on which direction you've come from. Any questions or comments or anything, please?
Just fantastic. You've given me a whole lot to think about, because plotting is something that I was scratching my head over, having just imported a JPEG into my Python and then displaying it, and it was just rubbish. And I was thinking there's just got to be a proper way of doing this. So,
well, last night I heard you say, well, I've been looking at using Visual Basic and Excel, and I was thinking, oh my giddy aunt, you definitely need to come to my lecture tomorrow.
Yeah. No, absolutely.
But that's that. You use the tools that you're familiar with, don't you? And that's what we all do.
Yeah.
Python's got a lot of tricks. Obviously, the great thing about Python is that the science community, the professional science community, they all the stuff they do is all available free of charge. It's all open source. So we all need to benefit from that, and it's all out there. If you can get into these Jupyter notebooks, especially, I know they seem a little bit quirky and complex when you first see them, but once you get to grips with those, you can just spend hours just going through people's Jupyter notebooks. In fact, sometimes you think, I need to get away from this and go and do something, because all I've been doing for the last 3 days is reading other people's Jupyter notebooks. It's informative. It's good.
That was an excellent introduction. Thank you.
What was that, Andrew?
I thought it was an excellent introduction.
Good. Thank you.
Say thank you.
Well, do it. Would you like me to put all those other things in a slightly more coherent form for another session, maybe in another month or something?
Absolutely.
please.
Schedule a date. That would be fantastic.
All right, I'll talk to you about that then, Paul.
Yeah, we will do that.
Good. I'm hungry now. I don't know about you lot. I'm
Yeah. Yeah. Go and enjoy your lunch and have a beer with it, I would think.
Well, that's a bit devilish. I don't know. I might have to. I've got things to do this afternoon. All right.
Yeah, no,
Thank you all very much for
Cheers,
bearing
Andrew.
with me and with all my
Yeah.
foibles.
Thank you very much.
And we'll see you all next time, hopefully.
Yeah, great. Bye bye now.
Bye-bye.
Bye bye.
Nice to
Thank
see
you.